So, hello everyone, and thanks for having me. Thanks, Guillermo, for having me here. And by the way, you have to say Guillermo. The other thing you say is not correct. Yeah, my name is Alvaro Videla. I'm from Uruguay. For those that don't know, these are actual gaucho pants, and these are actual gaucho shoes. So I'm bringing you the culture of South America. The talk is called Metaphors We Compute By. But before I get into that, recently I wrote that blog post, how I went from selling food in the street to working in tech. You are welcome to read it. It's on Medium. Because I don't want to do an about myself right now, because it's hard to define just, in 1 second, let's say. Anyway, back to the talk. This talk, if you want to get out, hang out, is totally fine because it's already published online. It's on the ACMQ, it's by the same title, Metaphors We Compute By. You have the transcription there. Anyway, getting into the talk. The year is 1980, and back then, George Lakoff and Mark Johnson published a book called Metaphors We Live By. As you can see, the title of my talk is not original at all. After this book was published, everybody wrote a paper or whatever, which is metaphors we design by, metaphors we, I don't care what, by, metaphors we drink Club Mate by, I don't know. So what's important about this book is that they bring out the thesis that metaphor isn't just a matter of poetry or rhetorical flourish. It's not just part of literature and just to make things sound nicer, let's say. There's a more deeper way on how metaphors works in our brain. Actually, this idea was even brought forward back in the 30s by another rhetorician that also started seeing that metaphors aren't only a thing of literature. And why do we care? Because they say, okay, metaphors, they dictate how we think, how we behave, how we perceive, how our conceptual system is built. And the thing is, they are cognitive scientists and linguistics, this Mark Johnson and Lakoff, and they wanted to study how we build concepts and how the brain works, but you cannot like grab a person, open the brain, and see what's inside. So the first proxy they found is language. That's why they took language and metaphors and so on as a way to study our conceptual system. And the first example they give is argument is war. What does it mean? It means that the whole way we conceptualize argument with another person is based on the war metaphor. And they give examples like, your claims are indefensible. These are things we say because subconsciously we think argument is war. Or he attacked every weak point in my argument, or I demolished his argument, I never won an argument with him, or his criticisms were right on target. These kind of things is because we took, as a culture, argument is war. This is how we talk about, there's a microphone doing things. This is how we talk about metaphors day to day. How we talk about argument day to day. And this is very important because they say what is arguments was dance, that we need to cooperate together to get to a common goal instead of just trying to destroy the other person, because I want to win this argument. That's the thing. And the book keeps going around this concept and trying to understand how we build ideas and so on. So that's a question they ask. What if argument will be seen as dance? What are we going to build around that idea? But I see your faces, you're not convinced, okay? So let's talk about politics, because every time somebody's not convinced, we talk about politics. There is an article from the BBC called How Metaphors Shape Women's Lives. It's really interesting how they analyze that part, but I'm just taking from a different topic. There was a study of crime in different cities, and they tried to ask two different groups how they will solve the problem of crime in their cities. For some of them, crime was described as a wild beast preying on the city, and to another group, a virus infecting the city. And the solution that a student presented to reduce crime were fascinating. They say 75% of the BEAST students thought jail or punishment would resolve crime, and 25% suggested social reforms. Whatever. Thing is, both had the same data, the same numbers, everything. When they were asked, why did you choose that solution? Because the numbers say so. No, because we told you there are wild bees prey in your city. Just imagine how we talk about immigration today. How the people they want to save in the States and keep them, they are called dreamers. They are not these Latinos anymore. And I get really pissed off about how they talk about Latinos in the States. But anyway, see there, stop deportation. We need to have this kind of way of talking about these different problems and the right metaphors put forward the ideas in totally different way on how they affect our brains, our thought, and so on. But I see you are not convinced, so let's talk about feminism confronts technology. This study from the 90s, actually, this book references this other author, Coburn, from 1985, and they saw that when masculinity, or the cool macho guy that I'm the super hacker, wanted to push women out of computer, they started to change the values of what hard and soft meant. So when we made everything so around masculinity, like they say, masculinity is expressed in terms of muscular physical strength and aggression, and in terms of analytical power. And then we wanted to fortify how the industry is, why it's cool to be a programmer, why am I really there and I want to show who am I. And all those metaphors started to grow, and then we push some people out of the industry, we keep some people in. And based on what you say, you can really think who you keep in and who you push out. You're probably still not convinced. So, human resource management. If you have this kind of people in your company and they think you're a resource, they think they can just replace you. Haven't you had a manager that thinks that you're a programmer and you can just be swapped by somebody else, like you swap RAM on a computer? Good luck with that. Because we are not resources. We are programmers, we are people, we are complex beings, but not just replaceable beings. Another way of how metaphors shape us. And final, trigger warning. There is a problem when you give platform to racists in tech. Don't do that. Yeah. There is a conference in the US that I'm not going to name, but they brought a blog post justifying why they bring Nazi sympathizers as keynoters. And they have a blog post say wrestling with inclusion at whatever the name is at conf. And I ask myself, why are you wrestling with inclusion? Go and talk with inclusion. Get together with inclusion, and you will solve your problem. But if you keep wrestling with inclusion, it's probably not going to work. But let's talk about computers. You probably saw that movie. There is a really great book, Hidden Figures is the name, which back in the day, before our beasts, we had persons, people being computers, people doing calculations for engineers or whatever. One day, we had this machine that could do these calculations automatically, and we needed a name. So it was like an automated computer. That, our very field starts as a metaphor, because we didn't have a word to explain what these things were doing. Because metaphors, they enable understanding. We use them every day just to explain things that is hard to have words for, or that we don't even have words for. Even most words are just dead metaphors that we don't care anymore about whatever they were meaning back in the day. So Shakespeare, he says, Juliet is like the sun. We understand that probably Romeo cannot live without Juliet. She is the light of his life. His life is going around her all day, and so on and so on. But we don't have a one-to-one mapping in metaphors. If you try to think, this doesn't work because it doesn't cover that corner case, yeah, that's the point of metaphors. They transfer concepts from one area to another, like patterns, but they don't really match everything. It's like a map. You don't want to have a map with every detail of a city like Borges said on his story, because that map will be completely useless. And how big has to be that map? You need to abstract. And because we abstract, we have metaphors like this one. But we don't think like Juliet gave me skin cancer, because that doesn't help at all to understand what Juliet is for Romeo, right? So there is this other book called The Geometry of Meaning, Semantics Based on Conceptual Spaces by Peter Gardenfors, which I think is from the Netherlands or Belgium. But there, east or west. Which, by the way, small historical note, east-west. When Darwin went to Uruguay, the people in the countryside, they had no idea what a compass was. So Darwin was there in some town in the middle of the countryside, and he said, so there's Montevideo, there's Punta del Este, there is I don't care what, and they say like, wow, this is like a magician from Europe. No, he has a tool called compass, right? Anyway, this book says that metaphorical mapping, preserve the cognitive topology of the source domain. So he analyzes metaphors using topology. So they preserve the cognitive topology of the source domain in a way consistent with the inherent structure of the target domain. Metaphors transfer information from one conceptual domain to another. Why I understand the sun is so important to me, I understand Juliet, how is she important to me. But its transfer is a pattern rather than domain-specific information. There are no atoms blowing up inside Juliet, let's hope. A metaphor can thus be used to identify a structure in a domain that would not have been discovered otherwise. And we will see this later in programming. And for me, metaphors in the brain, they work in a way like the graph isomorphism problem. You have a thing with a shape here, another one, and our brain is kind of doing this matching and so on. The animation is not mine, it's completely stolen from that website. So they say this is how metaphors create knowledge, when they find mappings from one way to another, one domain to another. But also metaphors, they can obscure understanding. There is a telegraph. Like telegraph means far writing. So back when they were trying to create this far writing machine, they were thinking about far writing devices. Very complex things to write down messages across the network. And once they understood that actually you don't have to really write something, you can encode things. This was when Braille started to be used as a system for writing for blind persons. They see, okay, I can encode my language. And then Morse came up and say, yeah, we can do with the finger, like you do a lot like this, and then you send message to the other end. And when I say send messages, that's also obscure understanding. For us, it's really clear what that means. But for people back in the day, they used to go to the telegraph office, send this letter to my son somewhere, and the telegraphist was typing it, and the other person said, yeah, but why don't you send the letter that I have on your desk? Because they didn't understand the whole thing of this telegraph. And Nicholas Carr says, sometimes our tools do what we tell them to, other times we adapt ourselves to our tool requirements. And it happens that metaphors are the tools of thought. Depending on the metaphor we use is what we get or not out of it. But you probably want to hear about metaphors and code. There is a really great paper from 1955, or I don't care when, but nobody knows the author. This is the best unknown paper. It was found on Donald Knuth's archives, and don't even Knuth know who gave him this paper. But the thing is, this paper discusses what a programmer should be doing. And a programmer Should we write in code, he says, for other programmers? The main idea is that we need to explain how we solve a problem to another person, and that explanation is the program. So that is a really powerful idea. Like they say, the elegance of a program is how much knowledge is transferring. The computer is just a tool that manages to run the algorithm really fast. But please forget about the computer. What matters are we, the humans, using the computer. We can either adapt ourselves completely to the computer, or we can understand it's just yet another tool. I hope there is a better one someday. I don't know. So he says, to program is to write to another programmer about our solution to a problem. That's from that paper. And then from structure and interpretation of computer programs, they say programs must be written for people to read and only incidentally for machines to execute. So depends on how you focus yourself is what you want to get out of the program. Yeah, maybe you need to write some very efficient graphics code for your GPU. Okay, do whatever you have to do. But in most common scenarios, we are writing software to solve like day-to-day problems. So it has to be clear what we are implementing. In programs, types are the characters that tell the story of our programs. And I'm talking here at types in the sense of Haskell static typing, types in the sense of what Barbara Liskov says on this paper, Programming with Abstract Data Types. By the way, this paper, 1974, she had to argue with people that you have to abstract, because people didn't like, no, I need to, I'm just barely getting with functions and structural programming, so don't talk to me that I need to have these big structures telling things about my code, whatever. But when we abstract, we communicate intent in our program. But because without type, we just have operation on the stream of bytes. In 1951, there is a paper about the subroutine by David Wheeler. He invented the subroutine. And he said there is no need to have a subroutine. But if we want to have code that is easy to read, easy to share, and so on, that's why we do this. And we do the abstraction because we want to understand and manage software. It's totally unrelated to the problem of how can be done in the computer. So the computer is just a tool. Are we adapting to the computer, or are we telling the computer how the rules are? I prefer to dictate the rules, or not dictate, but to tell this is my philosophy on how things should be done, not writing assembler or even just code like binary. So back to code, when you choose the right data structure, you are telling something about your program. Let's say you need to keep track of users, and a set of users, or a list of users, or whatever you want to name it. If you can keep it in an array, or you can put them in a set. Let's say somebody told you they have to be unique. When the data structure is a set, you are telling me already that those elements are unique, not the same with an array. Can be backed by an array or whatever you want, but the set is already telling me information. Or if I have a linked list, I know how I can traverse that, but I cannot do like O1 lookups. If I have a queue, I know there will be an order on how data will come out and go into that queue, or the same with the stack. Those things that seem like everyday concepts, they are augmenting the explanatory power of the programs. And you say, okay, did I come here just to hear about stacks and queues? I mean, come on, dude. No, we will get there. So a program explanatory power is a measure of its own elegance. If your program doesn't tell me anything, yeah, nice. There is a code golf competition next month, maybe send it there. Data structures, they have explanatory power, and they can introduce cognitive leaps. I can talk all I want about task scheduling, about how I need to execute tasks in certain order, and then based on who came first, I will do I don't know what, and keep going around. Or I can understand I have a queuing problem, and when I have a queuing problem, I have the whole power of queuing theory for me, and the whole mathematics behind it, and so on, because I understood what was this problem I had exactly about. When you are trying to decide how you want to scale your application, at the end of the day, it's queuing theory. You want to know if you want to have deployment of now in San Francisco, Belgium, or wherever are the data centers. That's a queuing theory problem. You need to know how much things go into your system, how fast are you processing, and then you decide to distribute or not. But that's literally just a queuing theory problem. Route planning. It could be quite hard until you understand it's just a graph theory problem. And when the metaphor to understand the city is a graph, that map can be represented as a graph, then you have the whole power of graph theory to getting from A to B. Database replication. Back in the 80s, the guys from Xerox, they tried to implement a new way of replicating data. And they understood the problem as doing rumor mongering, basically spreading rumors, like the South American telenovela style of replication. And you are still awake, okay. And the idea is like you have a computer, this computer tells about some information to next two, this one to two more, and so on, and you spread information. That is really cool, nice metaphor. You can work with it, you can explain how you think is going on, but it's hard to reason about. It's hard to know whose uncle is getting married to whose I don't care who, right? So they understood that actually what they were doing was epidemics. That's why those algorithms are called like epidemic replication. And when they understood that, they had this book, The Mathematical Theory of Epidemics from the 50s, that explained how to prevent the spread of an epidemic. They wanted to do the opposite thing, but the mathematics is the same. They want to spread things faster. So please don't show this slide at the airport. It's not going to work well for you, I guess. But yeah, here you see, like, this metaphor is really cool for explaining things, but when you get this other one, you get the mathematical power behind it. And we probably, all of us have had flu, so we also get it, what it is. So, is everything a metaphor? I don't believe you, right? Let's read about distributed system literature. In italics, you have the metaphors. There are more there, but I don't want to bore you, right? Whenever nodes need to agree on a common value, we start consensus, algorithm to decide on a value. There's usually a leader process that takes care of making the final decision based on the vote it has received from its peers. Nodes communicate sending messages over a channel, which might get congested due to too much traffic. This could create information bottleneck with queues at each of the channels backing up. These bottlenecks might render one or more nodes unresponsive, causing network partitions. Is the process that's taking too long to respond dead? We won't know unless we say them out, blah, 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 blah. But just go wherever you want. You will see there are metaphors everywhere trying to explain concepts. But for some reason, I have this slide called buzzwords. Let's see what it is. Yeah, containers. Woo. Containers, I think, is a really great metaphor, because imagine the whole world that this enabled, because we started thinking about deploying stuff in the sense of containers. They are standard. They can be shipped anywhere. They can be put on trains, ships, trucks, whatever. They are stakeable, they are reusable, and so on. When we think about containers, we don't think that the biggest ship in the ocean polluting the world is a container ship. You probably don't think about that. It's come from Switzerland, by the way. But yeah, you think all the cool things about containers, and it's really easy to explain and to go into an elevator and tell your VC why he has to give you money, let's say. So it's a very powerful metaphor. But also, this is Haley, the guy from the Comet. he created a diving bell because he wanted to rescue ship wreckage. So maybe there will be a startup in the future that will be rescuing the whole wreckage of this container frenzy world we have now. I'm pretty sure there will be, because technology comes and goes all the time, right? So that's your free startup idea. I know you're in Berlin. There's probably a VC somewhere. Get in touch with me later. Another one, microservices. Woo, I see everybody clapping, right? Microservices, they came really cool because they have all these metaphors like decentralized governance, monolith versus microservice. Who want to have a monolith? Who? I mean, only the guys on that 2001 movie, right? Isolation. You can collaborate. Small is better. Big is cumbersome. Who wants to be the big guy? I want to be David against Goliath, whatever. And all these metaphors put forward an idea that the people in the airline world, there is somebody in the back, we're always asking, ooh, the two Erlangers in the room. In Erlang, we were like, but this microservices, this is literally just Erlang. Like, this is the last sentence on that microservices blog post. In another direction, one could argue that microservices are the same thing as the Erlang programming model, but applied to an enterprise application context. And say, okay, what, are you sad that they didn't get your Erlang thing? No. My point is, what is Erlang's elevator pitch? That is really a hard one. Imagine going to a VC and telling, yeah, we have this actor model that they do message passing and we kill children, and I don't know, because these are commands in Erlang. No, it's not going to catch up, but the microservices, they have a really cool way of explaining how things work. So I'm sorry, Erlang, but not approved. So the point is, we need to first get people to understand things. I think it's really cool, for example, that here is called now, and Zeit, like time. It gives you the sense that things will go fast. You won't be waiting for, I don't know. So when I first saw like a GIF, I think that Guillermo posted on Twitter with this whole now, I was impressed just by the wording behind the whole concept. So get people to understand things. Then we can explain how things actually work. You have all this super cool concurrency, Erlang virtual machine. I don't give a, Tell me, what can I do with your tool? For example, when I was talking about RabbitMQ at every other conference in Europe, people will come to me and they say, is RabbitMQ a shop server? No, it's not. RabbitMQ is a queue server. Excuse me. And fail. Oh, no conclusion. Wait. The failure here is like, yeah, it's a shop server. You can use it as a shop server. Let's talk about jobs. That's cool. And yeah, with messages, it's a higher abstraction than jobs. You can do many more things with messages. But what? Is Rabbit like WhatsApp? I mean, you know? So let's understand what Rabbit is, and then we go to the next. It's like the other people, Kafka. They just have this really cool log metaphor. We are super fast, right ahead log, everybody loves us. And then behind the scenes, it started to build the same enterprise messaging thing. Sorry, did I say enterprise? I should have said streams. That's the cool buzzword. But same thing, different flavor. Conclusion. We need to master the art of metaphor selection. We need to master the art of meaning amplification. And at the end of the day, our program will be or is the metaphor for the solution we found. We wanted to explain either future us or somebody else on the team how we solve a problem. The program is that exact metaphor. Depending on how well we choose our characters or types is how powerful this message will be, or will be just a mess that nobody understands, nobody wants to maintain. Those are the references, more credits, and thank you very much. Not sure if there are questions or there is time for questions. okay? Remove the master-slave metaphor, please. Bye.